So we're almost done with our coverage of the Java Completable Futures framework. Let's start by discussing the benefits or the pros of using completable futures. And we're going to kind of compare and contrast completable futures with the Java parallel streams framework, and we'll use the image stream gang case study to illustrate these points. And of course, we could do the same thing with other examples out just as the one that we've looked at most recently. So one of the things that the completable futures framework does is it greatly simplifies the programming of asynchronous operations. Without completable futures, you end up with this somewhat circuitous, convoluted way of handling the results of things that finish asynchronously. With completable futures, you can handle them in a much more linear way. And the reason why you can do that is because the completable future framework provides all these completion stage methods and other things like arbitrary arity methods that support dependent actions that are triggered upon the completion of asynchronous operations. Maybe I should probably say the benefit is it triggers dependent actions upon the completion of async operations. That's the thing that we get, and that's what these, like then apply async, and then apply, and then compose async, and then combine. Those are all examples of completion stage methods that are triggered automatically when something finishes running asynchronously. And that allows us to do several things. It allows us to be able to fork asynchronous operations. As we do here, we have supply async kind of forking us into task 2 and task 3. We can chain stuff together like we see with task 2 with then apply async followed by then apply. And we can join things together again as we do here in task 4 with then combine. And it's relatively intuitive. Once you get the hang of the concept of completion stage methods, it is pretty straightforward to do it. And why it's pretty straightforward to do it is because these completion stage methods, or these dependent actions that are triggered, enables programs that are asynchronous to look pretty much like programs that are synchronous. So you can see here that we first do supply async. When that finishes, we then have then apply. When that finishes, we then do then accept. So it looks pretty linear, even though the computations are taking place in the background, doing stuff asynchronously. So that's a real nice benefit of using the completable futures framework style of async programming. Another nice thing here is that these asynchronous operations run in parallel in a thread pool, so it simplifies optimization, I suppose, as opposed to simplifying programming, but it simplifies the optimization so that asynchronous operations run in parallel in some type of thread pool. Now, by default, it runs in the common fork join pool, but you can give it other kinds of pools. You can use a cached thread pool. You could use a fixed size pool. You could use a non-common fork join pool that you could customize in some way. You can make your own custom thread pools altogether where you can define how they behave. It's a little bit of a stretch because it's probably overkill. Most of the stuff that comes out of the box works just fine, but you have control over where the computations run if you choose to exert that control. Another nice feature is that there's typically very little, if any, need for explicit synchronization. You don't have to put locks in, usually, unless you have shared mutable state for some reason. We'll briefly talk about why you might want to do that. And you don't need to explicitly create threads. Those threads are created automatically for you based on the type of executor pool that you use to run the computations. Now, if you do need to handle shared mutable state, if there is state that needs to change, then you can use various Java libraries. There's things like the concurrent hash map library. There are things like the library that's used for doing computations that might interact with the file system and so on and so forth. So those would be examples of things that you could use if you needed to have shared mutable state. Oftentimes, completable futures are more efficient than parallel streams. As you can see here, when we run the image stream gang program in a particular context, we get better performance with completable futures than the parallel streams. They're actually doing quite well relative to the sequential versions, but completable futures are a little better. And the reason for that really has to do with I/O-bound computations. So if you have I/O-bound computations, you're going to get more of a win from completable futures than if you don't have I/O-bound computations, just because it's a little leaner, a little meaner, the way that things are using asynchrony and concurrency for I/O-bound stuff, whereas there's just a bit more overhead with streams. even though parallel streams give you a win relative to sequential streams, as you see in these results. But of course, your mileage may vary, and so you need to benchmark stuff. And there's actually a cool benchmarking framework that's called the Java Micro Benchmark Harness, kind of a funny name, called JMH. And so you might take a look at that to see how that works if you're curious in doing benchmarking. It's often the case that combining sequential streams with completable futures will be beneficial. You can use the streams framework to guide the overall flow of control without using explicit types of control constructs like if statements or loops. You can use the stream mechanism to do that. And then you use the completable futures portion to do the asynchronous operations efficiently in parallel. So it's a nice combination of things. However, as a general rule of thumb, combining parallel streams with completable futures is probably overkill. You're usually better off using sequential streams with completable futures to get that control flow and asynchronous processing stuff worked out. It's usually not necessary to get completable futures and parallel streams. And there's a funny little meme here that says, overkill. Why have one when you can have 200? And it's a minivan full of seatbelts. So just to give you the metaphor, you don't need that much concurrency at some point. It's going to be excessive. So that's the end of our discussion of the pros and cons of asynchrony using the Java Completable Futures framework.